We're going to give everybody just a minute or so to get settled in before we begin. All right, good morning, everyone. Thank you so much for tuning in again to Velodyne Lidar's digital learning series, Automation and Safety During COVID-19. I'm Pamela Gauchi, your host for the next 40 minutes or so, and joining me is my co-host, Mary, who is running slides in the background. Today, we'll be doing something a little bit different. We'll be joined by two guests during our interview, which is a first for us. Both of our guests are with AutonomouStuff, which is part of Hexagon's Autonomy and Positioning division. I'll be introducing Bobby Hambrick and John Buszek in just a few minutes. But first, a little housekeeping before we begin. Let's take a quick look at our agenda so you know what to expect today. We'll start off with a brief overview on Velodyne Lidar, specifically with a look at our UltraPuck sensor. Then we'll move right into our interview with both Bobby and John for about 30 minutes or so. I'll save the last few minutes for audience Q&A, so be sure to use that Q&A button at the bottom of your screen to ask questions anytime during the episode. As always, we are recording today's episode, which will be available to watch on Velodyne Lidar's YouTube channel. So let's begin. Here you see just a few examples of Velodyne Lidar's suite of LiDAR sensors. Our product portfolio provides real-time perception data that enables autonomous driving and advanced safety. Now we're going to focus for a couple of minutes on Velodyne's UltraPuck, one of our surround view sensors designed with the autonomous vehicle in mind. So let's take a closer look at Velodyne's UltraPuck sensor. The Ultra's 200-meter range and 32 channels provide enhanced resolution to identify objects easily. Velodyne's UltraPuck generates 1.2 million points per second in dual return mode. And since it's built on Velodyne's 558 patent, it provides a full 360-degree environmental view to deliver accurate real-time 3D data. Now let's see what that kind of data looks like. In this video clip, you can see the high-density, long-range data captured by Velodyne's UltraPuck on a drive through Nashville, Tennessee. In addition to the features I've already mentioned, the Ultra offers firing exclusion and interference mitigation features. It also includes advanced features for minimizing false positives, as well as best-in-class power efficiency and temperature range. Add to that pricing and an encapsulated package for handling harsh environmental conditions and weather. And here you really get a sense for just how detailed of a point cloud the Ultra is capable of producing. And here you can see how the Ultra is actually integrated into one of AutonomouStuff's vehicles. Now during our interview this morning, Bobby and John will tell us about the work those vehicles are currently doing on the road. So now I'd like to introduce both of our guests. First, Bobby Hambrick, founder, president, and CEO of AutonomouStuff and Chief Autonomous Officer at Hexagon's Autonomy and Positioning division. Welcome, Bobby.
Hello, everyone. Thanks, Pam.
Thank you for joining us today. And I'd also like to welcome John Buszek, VP of Products and Services at AutonomouStuff. Welcome, John.
Oh, thanks for having me.
Great. So I'm gonna dive right in here with a few questions for Bobby. Bobby, can you start by giving everyone an overview of what AutonomouStuff does?
Yeah, of course. First off, thank you for that great introduction, Pam. It was pretty awesome, and thank you for having us today. So AS has evolved and reinvented itself over and over and over again since I founded the company. But essentially, AS has always been very customer-centric, and we've always focused on what the customer needs. And that's changed over the years. So now we're providing all the individual pieces of technology, complete automation software stacks, as well as a variety of different engineering services to help enable, accelerate, and help our customers deploy their automated solutions.
Great. So then, and this next question is twofold. So going back in time to before AutonomouStuff was formed, how did you become interested in robotics? And then what led you to recognize a gap in the supply chain where robotics companies were having difficulty getting technology they needed to build applications?
My background, I was an industrial engineer. So I provided factory automation solutions to a large variety of different types of factories around the the tri-state or quad-state area where I live in Illinois. And I got to the point where a lot of the innovative companies were coming to me asking me for questions on how to provide solutions to automated guided vehicles, which were inside of the factory, but also some of the autonomous driving applications outside of the factory. And then I started providing sensors and different technologies and some guidance. And somehow I just became the guy that provided the technologies to these companies for this. Which made me question why I was the guy. And then apparently there was a large gap in the supply chain, and that's kind of how I got started.
Great. And now you started the company in 2010, and you've continued to lead the company after being acquired by Hexagon in 2018. Can you tell everyone why that relationship with Hexagon was a good fit for AutonomouStuff?
Yeah, absolutely. You get to a point in a company where you need fuel to continue to accelerate growth and to help you get to the next steps of business. And AutonomouStuff had a global footprint, but nothing like Hexagon has. So first off, Hexagon, their focus is to empower an autonomous future. So right off the bat, we're completely aligned. You can go to their homepage and you see that as their tagline. Second, they're very strong and a very mature global company with a presence everywhere. And as we were growing, we had some limitations to get to our customers wherever they were in the world. So Hexagon gives us that global footprint. And third, Hexagon has hundreds of companies that have great technologies, software and hardware, from brands like Novotel, Leica, MSC, and there are many other well-known brands. And there's a lot of knowledge there, and a lot of experience in safety and production. And so the alignment was give us an opportunity to have unlimited access to customer support and the experience and maturity that we need to help fuel our growth.
Yeah, so now a decade later after forming AutonomouStuff, you have so many different types of customers and so many customers. Can you give us a sense of who those customers are and what they come to you for?
Yeah, it's been an amazing decade of business, and we have actually had an opportunity to have thousands of customers worldwide and such a large variety of applications. So a lot of people think of us as just a company that's providing solutions for automotive or automotive R&D, but that's not the case at all. And we have supplied something to almost every automotive OEM and tier 1 supplier and the whole automotive supply chain, but also in the agriculture business, in the mining business, in the marine business, academics, almost every university in the world that has some type of research for autonomous driving is a customer of ours. So from vehicles from 400-ton mining trucks to little robots delivering burritos on the streets, right? So we've had we've had a great time throughout the last decade providing so many different solutions to so many different customers.
Shifting gears here a little bit, and this question is for either one of you, whoever wants to take it. How do you think COVID-19 is now impacting the development of the autonomy business, especially with testing?
Well, I can take that one, Bobby. We're certainly seeing with COVID-19 even more of an emphasis on simulation testing. Actually, we have a video that we provided to show a little bit of the simulation-based testing that we do to make sure that the autonomous vehicle platforms that we provide our customers come in a state where they're working, right, and meeting their requirements. Simulation is huge for autonomous driving development before COVID-19. But when you encounter a situation where suddenly engineers can't go to the office, even if they wanted to, or can't get into a development vehicle even if they wanted to, you can imagine that simulation becomes somehow even more important, right? So simulation is big. And then I think also remote access in the vehicle is big. With COVID-19, maybe if there's a way you'd want to reduce the amount of people you have packed tight in these development vehicles for testing. A lot of times in my career, I've seen an ideal state where you have your safety driver, who's the person who's only thinking about whether or not the car is doing what it's supposed to do. And if the autonomous vehicle does something that doesn't seem right, they can immediately take over control of the car. And then often you don't want to have someone in the passenger seat who's maybe looking at a laptop, watching the performance of the system from like a diagnostic and measurement perspective, and could say this doesn't look right or this looks good, etc. Maybe tune some knobs, things like that. And as things have become, a little bit more difficult when it comes to having lots of people in the car, the idea that someone could assist that safety driver and maybe do their laptop duty instead of in the passenger seat, but through some type of remote access, that's another type of workflow that I think we need to make sure that we're really good with in order to be as effective as we can in the era of COVID-19.
So, John, your work with engineers and customers involves consideration of some really complex automotive safety standards. I want to talk a little bit more in depth about safety and testing, but before we do that, can you define for us, what does safety mean when we talk about autonomous vehicles?
Well, at the highest level, it's the idea that any person inside the autonomous vehicle or any person outside the autonomous vehicle would never be put into an unsafe situation because of something that went wrong with the autonomous vehicle, whether it's a malfunction or something just broke, or just a design flaw in how the system was engineered. So when you think of it that way, you could see the engineers who develop these vehicles have a lot of work to do.
So, and how do you go about developing and testing for standards like ISO 26262, which is a functional safety standard for electrical and electronic systems in production automobiles? How do you tackle that, and what are the challenges?
Well, that's the type of question you can talk a long time about. There's a lot of challenges. And when I talk about safety and autonomous driving with people, typically three particular challenges come to my mind. One is trying to build safety design early into the development. With autonomous driving or with a lot of systems, when you first prototype a system, your goal is just to achieve some level of basic functionality. Like you've heard this term, proof of concept, right? To prove that some level of functionality could be done and show someone that the value is there. And typically in that phase, you just want to go as fast as you can to get to that basic level of functionality. And maybe you want to, when it comes to things like safety or security, you say, oh, maybe I'll think about those things later. And I'm just going to race to showing some level of proof of concept. The problem is you could find yourself 1 or 2 years into developing a prototype, asking yourself if this thing you've developed actually has a path to being safe. Or maybe there are fundamental flaws in the design that you've in some ways committed to that just make it very difficult to be safe. So how can we find a way to prototype quickly while also keeping safety in mind? That's tricky. A second challenge that comes to mind is just safety in the presence of failures. That's a huge thing. That's what ISO 26262, which you mentioned, is all about. And you have, as an engineer, you have to look at the system and say, what are all the things that could fail? And when it comes to all those things that could fail, how do we detect it? How do we know that all those different things have failed? And once we've achieved a system design where we feel we would know it for all those different things that would fail, how do we design the system such that it would still be safe even when that failure happens? And so there's a lot to do there. And it turns out that when the system's very, very complex, it just means there's more and more failures that need to be considered. And so the reason that's challenging is, autonomous vehicles with all these processors and all the network and the software, just the vehicle itself, there's just so much that needs to be analyzed in order for a team of engineers to feel that it's safe in the presence of failures. So that's the second. And then I'd say the third big challenge that you face, and there's more than three, but just if I had to just come up with three off the top of my head, I think is the workflows you need to follow. On one hand, you could say, let's just think about all the different things that could go wrong, all the different things that could fail. Another thing you could say is maybe there are best practices in terms of an engineer's day-to-day work, how they do their job. To where if they follow those best practices, the likelihood of them making a mistake or there being a flaw in their design would be reduced. And so that's a big part of designing safety is the workflows that you follow in the design. And it turns out that in most cases, if you want to follow best practices for design to eliminate mistakes, typically you need to work slower than faster. And I've seen in my career that, achieving safety or designing safety critical systems is definitely not about going fast. It's about going slow and not allowing yourself to race and just being more disciplined. And so, if you have to go slower to achieve the level of safety you're targeting, it just means more time, more cost, which of course is challenging to a business that's trying to be successful in autonomous driving.
Yeah, and I will mention before I get to the next question, you're talking about standards for failures, but you also have to test when there's not a failure as well, right?
That's right, exactly.
Yep. And now autonomous vehicles gather massive amounts of information. So can you talk a little bit about safety as it refers to cybersecurity and testing, and how do you manage those two different workflows?
Well, with safety, we talked about thinking about all the things that could fail. And with security, you have to think about, what are all the different ways this system could be attacked? And there's a similar analysis there in terms of how could it be attacked? How would we know it? How do you prevent it? That means that there's going to be additional design that goes into your system just to prevent it. Very similar to safety, right? When you look at the system, you say, wow, here's a big portion of the engineering that's purely about security. So that enters the overall complexity. And then when you add things to the system, specifically for the purpose of security, they need to work. Right? So that means you're entering more things that need to be tested, more things that need to be considered in the overall complexity of the system design. So I think you just look at it as just another bucket of engineering work that needs to be covered in order for autonomous vehicles to get to that product level they need to be at in order to hit the mainstream. And actually, we won't have time to go through it today, but we have a really nice webinar that you could Google search at AutonomouStuff, where we talk about ways that you can combine the workflows of safety and security, just so that things could be a little bit more optimal. When we talk about safety and security, you heard me say time and cost. And so any way that we can be more efficient with our engineering time is certainly helpful to businesses in autonomous driving.
So, and I'm curious because the technology is evolving so quickly. Are the standards driving the technology, or is the technology driving the standards, and how do you maneuver through that evolution?
I think it's a bit of both. If I look at the workflows that autonomous driving engineers were following when they started prototyping, in the early stages of AutonomouStuff's history as a company, I think those workflows certainly have changed as they started trying to follow standards such as 26262 and other safety standards. So absolutely, the standards are impacting the way autonomous driving engineers do their jobs. But I also think it goes in the other direction. I'm not sure that when the first drafts of 26262 were developed, people were thinking about neural networks and all the different non-deterministic behaviors you see in high performance autonomous systems. So I think it goes both ways.
So because we are Velodyne, I do have a couple of questions about LiDAR. I have one for each of you. So the first one, John, if you want to take, in addressing all of the safety issues that you're talking about, how does LiDAR technology help to ensure safety with autonomous systems?
Well, I guess you could say it's a high level. Certainly we could go into more detail, but a very important function for an autonomous system to operate safely is the perception system. LiDAR brings tremendous advantages to a system in terms of its ability to perceive the world. I remember the first time that I saw a LiDAR, actually the first time that I saw a Velodyne Lidar scan, as an engineer, Bobby showed it to me. I think it was like in 2013. It was a long time ago. But I remember where I was and being so amazed at that level of resolution that you get from that sensor. And I had some experience with ADAS products prior to that, so I was familiar with radar and familiar with cameras. And, you know, neither can give you exactly that. And the technology in LiDAR's only improved since then, of course. And so that's why I think it's become so essential in these systems, you know, that you have with autonomous vehicles, where you'd say, we don't need a person's eyes, right? This vehicle can do everything you can do with your eyes and more. And I think for that to hold true right now, certainly LiDAR is essential.
Now, for Bobby, would you say LiDAR is an essential technology, which John was just talking about, for your autonomous vehicles? And if so, why is it an essential technology?
Sure. The short answer is yes. But just like what John said, you know, every technology has a trade-off, and so no one can rely on just a single technology to provide a completely robust, completely safe autonomous driving solution in every scenario that exists, right? So just like John was alluding to, you know, these automated driving cars need to operate in most cases 24 hours a day or very often. And they need to see things 360 degrees at all times to make sure that they're as safe as possible. And you're not going to do that with a technology. You have to do it with the technology that's very precise and exact, and LiDAR does exactly that.
Great. So another question for you, Bobby, shifting gears again. Although AutonomouStuff now has offices all over the world, you do maintain your headquarters in Morton, Illinois, right next door to Peoria, where you grew up. Is that sense of community something that's important to you, and why?
Yeah, I absolutely do. So, you know, I was born and raised in the area, so I have a sense of pride of being here in Peoria, and also being able to raise or grow a business here, and also to give opportunities to those that I know and to those in the community that they wouldn't probably have otherwise had. And so I've given an opportunity for almost all of our employees to travel the world, and do business with some of the brightest minds in the world. And that's an amazing thing to be able to do in a small town in central Illinois. And I take a lot of pride in the fact that we're from Peoria.
Right, and congratulations, because just recently, for the second consecutive year, Peoria Magazine's named AutonomouStuff as the best company for innovation as part of its annual Best of Peoria Awards. And now, did you seek to create a community, you know, consciously at AutonomouStuff? And if so, can you give us 3 adjectives you'd use to describe the community that you've created over the years there?
Sure. I've always had a culture. You can go to our website and see some of our culture and what we're passionate about, but it's always been about, you know, work hard, play hard, have a good life-work balance, be passionate about what you do, but don't forget that you have family at home to take care of, right? And so the Peoria area, you know, if I were to reduce it down to 3 adjectives, I would say they've been very supportive. They're incredibly excited that we're here. I've become great friends with the local mayors and the local leadership. They love that we're there. They will do anything to support our growth or support anything that we need. And it's been, and that's actually been very helpful as we're trying to do these automated driving demonstrations and so forth. And we bring in, you know, we have a chance to bring in customers from all over the world, and they eat the local restaurants, and we get to meet the local leaders. It's really, really cool small town experience, I would say. I would also say that I would use loyalty. So the employees that we have here are very loyal. And I think when you're trying to build a core technology that takes a long time to develop, it's incredibly important that you have people who stick around with you and are loyal. And that's also what we get from being here in Peoria. The last thing is that family life balance. You know, I know in some other areas in the world, it's all about grinding day in, day out, you know, 20 hours a day. It's not really like that here. We work hard when we need to work hard. We put in plenty of our time, but we also have a good life balance mostly. So it's very family oriented, I would say.
Right. So, and then continuing on that topic of community, AutonomouStuff currently has research vehicles on the road just south of downtown Peoria as part of your Open Autonomy pilot program. Now, John, you oversee that program. Can you tell us about the program and what those vehicles are doing in Peoria?
Yeah, absolutely. You know, we had this big part of our business, which is providing these vehicle platforms to engineers that are trying to develop their own autonomous system or some technology that goes into the system. And, you know, it's just a huge accelerator for them. And what we found was that a lot of those engineering teams loved the idea of receiving the vehicle from us with different software running that actually enabled the vehicle to be driving fully autonomous. And so what we said is, okay, if we're going to deliver the vehicle, you know, with all the way to some type of public road capable autonomous driving software, along with all the different computers and sensors nicely integrated into that vehicle, we need to prove to ourselves that we know what we're doing with that software, and that we would be very skilled in helping our customers use the software and to change that full autonomous system, that development platform, into whatever they need it to be. And so we put it to the test in downtown Peoria. And here in this video, you can see Bobby's our safety driver that we were referring to. And here we're testing out one of the different software stacks that we try to enable our customers with for their development. So all the challenges that you face with you know, city autonomous driving in terms of where are the obstacles, you know, dynamic path planning, things of that nature. I think here we're looking at a roundabout, you know, another complex scenario in driving in a downtown area. You know, all these are tested and considered. And certainly if you can deliver a vehicle with this level of capability to an engineering team, you're going to make reaching their goals certainly expedited, right? And give them that boost that they need to, you know, develop these autonomous driving systems that, as we said earlier, are very challenging to develop. So they need all the help they can get.
Yeah, and also I'm assuming adding a lot of cost. So all of this testing and research that you guys are doing, I'm assuming, you know, you bring that to your customers so they benefit for that.
Oh yeah, absolutely. Think of it as, instead of everyone doing some level of testing on their own, one company can do some level of testing and then just distribute that to everyone, right? And bring down the workload of the autonomous driving community as a whole.
Yeah, great. So I want to get to some audience Q&A. So I have a couple of final questions, one for each of you. So for Bobby, AutonomouStuff is helping to shape the future of transportation. Can you give us a few highlights from your own vision of what you think that future looks like?
Sure. What a big question.
Yeah.
So, you know, when I started my career, the idea of simple urban driving and autonomously seemed impossible, right? And what John just talked about, we now can enable someone to get there in a single day, right? And so day one, they're driving in the simple urban environment. So that absolutely accelerates the development paths towards autonomous driving, and that's been going on for the last decade or something. So I think as technology continues to develop, of course, we're gonna start seeing more and more automation on the roads in a variety of different ways. Just yesterday, I think there was an announcement of someone releasing robots in the streets of San Francisco. You see a lot of activity right now in the trucking industry. Some people are saying, you know, it's going to be deployed in the next couple of years. Some people are still saying 5 or 10 years. But either way, we're going to see more and more and more of it. And it's going to absolutely change our way of life. Just like all the smart devices that we have in our life today, the current generation doesn't know how to live without them, neither do we. So the same thing will happen with the future of automation.
Yeah, and I assume when we're talking about autonomous vehicles, but infrastructure will have to change, right? Autonomous vehicles are going to have to do things like talk to traffic lights, for instance. So there'll be, you know, changes in infrastructure. Yeah. Yeah,
the more data that the vehicles have, the better they will be, right? And just like human beings, we recognize and see and hear and smell things, and we use that, all those sensors to make our decisions. An automated driving vehicle is no different, right? It has to think faster and better than a human being. And so the more data that it has access to, the better.
Great. So for John, I have a final question for you. This is also a kind of a large question, but what do you think is the next big breakthrough that we're waiting on to really advance the current industry?
The one area of innovation I think is related to safety. You know, of course, these systems have to be cost optimized to a certain level in order to have some mass level of adoption. And you have to add a lot of cost to the system in some cases to achieve the safety levels you want. So I think that's definitely an area of innovation, is just optimization the architecture to be cost optimized while meeting safety standards. And I think the other a big one would be in compute. Right, you know, you've seen a lot of these autonomous vehicles that have these gigantic, you know, server-style compute systems on board. You know, how can we get from that to something that's more similar to the embedded style electronics that are in production automobiles today? And I think there's also a lot of great development in that area of the overall design, particularly within the silicon industry, that I think also will help accelerate the pace of mass adoption of autonomous driving.
Great. So I'm going to go to some audience Q&A now. So these are for either one of you to take. So how many vehicles have you deployed or put on the road in the US or globally?
I guess I'll jump in on that. I don't know the exact number, but there was a time last year where we were building 40 to 50 a month. So there are hundreds out there that we have enabled, and hundreds of customers as well. So I take pride in saying, I self-proclaim that we have provided more automated driving research cars to more companies, or more technology for automated driving research, than any other company in the world. So it's been an amazing ride so far.
So I have a question here about maintenance on those vehicles. When you deploy vehicles, do you maintain those vehicles, or are your customers handling that?
It's a little bit of both, actually. So a lot of our customers take pride in building their own technology, and some of our customers don't. And so we have an engineering services team that is available to support our customers in a variety of different ways. And so depending on what the customer wants, and depending on you know, what they need, then we do everything we can to help make them successful.
And so I have a question here specifically for Bobby. How has the view of autonomous vehicles by the public changed since you first started AutonomouStuff?
Yeah, I think I mentioned it earlier. At the beginning of my career, first off, no one thought that it was possible. It was like a dream that autonomous driving would be a real thing, right? Maybe in the military or somewhere like that. And then like a year later, it was like, well, by 2050, we'll have autonomous driving cars somewhere. And now, you know, now we're seeing it today. So I think that, you know, it's changed a lot. And when I get asked a question about, is autonomous driving safe? And some people say, I never trust it. And then, but everyone has a smartphone in their pocket. And it's the same guys that said, I would never take my phone in my car with me because I wanted to get away from my phone at the house. And I think it's just human, it's the human nature to just begin to trust something once you start seeing it more and experiencing it more. So the more we see it and the more we experience it, the more natural it becomes. And we're getting there, right? And it's just going to get better.
So, and I'm curious, do you get to the people in Peoria when they see those cars, do you get feedback from the public? What's their reaction?
A whole lot of rubberneckers, right? Everyone's turning their head like, what the heck is that thing? And sensors all over it. And we have film crews around here all the time. But no, the community, again, is very supportive. We hold open houses. When we could, we had open houses, and we would showcase the technology to the local community and the local media and everything. So yeah, I think almost everyone around here knows about us now.
Cool. Great. So I have a question here about how thermal ranging and imaging and heat detection fit into AVs.
I can take that one. You know, Bobby mentioned that no sensor is perfect, but you know, the strategy of most autonomous engineering teams is to use multiple sensor modalities, so you can get you know, what many different sensors are good at fused together. I think certainly there could be a role of thermal imaging where you get some blend of the data that you could get from a RGB camera, but higher performance in low light conditions. So I think, you know, I could absolutely see certain applications of autonomous driving that, you know, get a huge benefit from what you get from thermal imaging.
Especially if you're trying to avoid those humans who have a temperature, right? Thermal camera.
Right, so I have a question here about how long is the process to build out a fully autonomous vehicle from start to finish?
You want to take that or you want me to?
Sure, go for it.
So I would say it depends on exactly what's in the vehicle. You know, we have, like you saw the video of Bobby, you say, okay, there's a vehicle that they already have running with a certain amount of sensors, with certain software. And so that's something that we could provide to a customer, you know, in pretty short order. Maybe a turnover time of like maybe say a month, for instance, between when we decide just what I want and next thing you know, you're running with the vehicle. And then you might have some vehicles where someone says, you know, I understand the thing that you've been testing or spending the most time testing, but I need a couple different sensors added here. I need you to tweak the software. And that's where it can take a little bit more time. You know, certainly Bobby mentioned the engineering services part of our business, and that's a big part of what we do. You know, there's so many different use cases of autonomous driving people are trying to tackle. And so there's not going to be, you know, a magic bullet or a one size fits all. And so we've really had to beef up our engineering team, our support team to be, you know, someone who has the skills and is very enthusiastic about helping customers with all the unique challenges.
Right, so just a couple more questions here. Do you collaborate with other AV companies on R&D research?
Yeah, I can jump in, and John, feel free to as well. The answer is yes. I think that you know, autonomous driving is one of the most difficult engineering challenges of mankind, and there's not a single company that can do this by themselves. And so even the companies pumping billions and billions of dollars into automated driving research, they're not doing it alone, and we are no different. Thankfully, we are within a family under Hexagon of companies that have a lot of the technologies like simulation and GNSS precise positioning and mapping and so forth. But we still work with a large variety of outside companies to make it what we do happen.
Great, so I have time for one more question. It's a question that actually involves LiDAR, but I'll let you guys take it. Asking about how the weather, things like rain and snow, impacts LiDAR performance, and how does the industry handle that type of weather?
Well, I can say that it certainly impacts it. And I think, you know, when you're trying to address a challenge, I think, you know, you have to assess baby steps. And I think, you know, the autonomous driving industry has said, okay, let's try to tackle ideal conditions. You know, when we talked about the things earlier, cost optimization, you know, meeting functional safety standards, getting to that point where we're so confident in the system that we would say this is better in terms of something like perception than what a human could bring to the equation. You know, that's a lot of work. That alone is a lot of work, even in ideal conditions. You know, when you say, okay, well, what if we needed to operate in more difficult weather conditions? You know, I think you probably say for something as complex as city driving, maybe we'll just push after the ideal conditions first, make sure that you have a system that if you encountered some of those tough weather conditions would at least know it. And then maybe you also have some autonomous driving development in more controlled environments, you know, where it's you know, the people that are there are more like workers, whether it's something like mining or defense or agriculture, where because the scope of the challenge maybe isn't quite as difficult as making a vehicle drive autonomously, you know, downtown San Francisco, maybe because the scope's a little bit reduced, you can actually say, okay, let's go beyond the ideal condition and tackle some of those inclement weather conditions.
I'd like to add something else there, Pam. You know, the LiDAR sensors have technology built into them that recognize the environment that they're in, and they have things like multi-echo technology. So to answer a little more directly is I think it performs really, really well for an optical sensor. It does really well in conditions where it's raining. But the problem is it is optical. So if it's completely blocked off or covered, you're not going to see something. Right? So you have to apply it in areas that make sense.
Yeah, we generally say if you can see it with the human eye, then, you know, with that weather, then the LiDAR is able to see it as well. So now we are unfortunately out of time. Thank you guys so much. If we didn't get to your question, no problem, because you have our contact information right there on your screen. So you can reach out to us directly with any questions about autonomous stuff and their autonomous vehicles, or Velodyne Lidar and our Lidar sensors. Now again, this webinar recording will be available to view on Velodyne's YouTube channel. I want to thank Bobby and John again. Thank you so much for spending your morning with us and answering all those questions.
Thank you for having us.
Thank you.
Thanks. And I want to thank our audience as well. And if you're interested in learning more about automation and safety during COVID-19, join us for our next episode on Friday, August 21st, when we'll be joined by a featured guest to be announced very soon from CARTA, an innovator of real-time mobile 3D reality capture.